Welcome to day 21 of the Advent of Code. Today is all about foods consisting of ingredients potentially containing allergens. Every ingredient contains at most one allergen, and every allergen is contained in exactly one ingredient. Okay, so first of all, I already prepared the parsing. So this wall of text is parsed into a sequence of maps where the ingredients are those guys separated by spaces, and the allergens are those guys separated by comma space. Okay, just regular regex stuff. Okay, so the first function that we want to write is this one. It takes basically the output of the parser as its own input. And then we want to compute that output. What does that mean? So let's think about this. If we look at the dairy, we note that the allergen dairy is contained in two foods, so it's not in the third or the fourth food. And if we look at the ingredients, then we note that MX is the only ingredient that is contained in both foods. Okay, and from that we can conclude that dairy must be contained in MX. That's quite nice. Okay, then for fish, or let's say soy. For soy, we only have a single set, which is its own intersection. And for fish, we have these two sets. And if we compute their intersection, then two elements remain. Okay, so basically we want for every allergen to compute the intersection of the ingredients of the foods that contain that allergen. That's quite a mouthful. Okay, so first of all, how do we compute the list of 3 allergens in total? So for example, we could start by mapping the allergens keyword over our foods. That would look like this. And then if we compute the set union, then we should get a single set consisting of dairy, fish, and soy. Let's see if we can do that. Apply set union. Yeah, oh, dairy, soy, and fish in that order. For sets, the order isn't really that well specified. Okay, cool. So we could, for example, start by looping over those allergens like this, and then this should give us the exact same result. 4. Okay, then we get dairy, soy, and fish in a sequence. We want a sequence of vectors, so we could put the allergen in a vector. Okay, so now we have already the first column, if you will, but the second column is missing those set intersections. Okay, so how would we compute those? So maybe let's start by looping over all the foods like this, but we are only interested in the foods where the allergens of the food contains the allergen. Okay, let's see if we compute that. I didn't use anything for the for. That's a classic mistake. So maybe let's say the ingredients of the food. Okay, then we get this, maybe a little more simple. Here we say dairy. Those are the 2 sets with the ingredients. Soy, only a single set, and so on. And now we only need to compute the intersection of those sets. Okay, so maybe let's do it here. Apply set intersection. Okay, that's looking good. That's exactly the output that we were supposed to compute. So let's just make it a little more beautiful, and then we're happy. Okay, so set union, I think I've used that in a previous video, and set intersection, quite useful functions. Cool, now we take that output as the input to the next function. That now says, looking at my input, we can immediately conclude that dairy is contained in MX, but we don't really know about the other ones. But okay, we can already say dairy is contained in MX. And now we can basically remove this line from our input and also remove MX from all the remaining sets, right? So we would remove MX from here, and then we can say, fish is contained in SQ. So we can remove the entire line from our input and also remove SQ from the remaining sets. And then we can say, soy is contained in FV. So we should be able to associate that perfectly uniquely without doubt. Okay, so how would we start that? Maybe with a good old, whoops, loop recur. Let's say our input are the possible ingredients and our output for now is an empty map, and we're going to fill that empty map with one entry per loop iteration. Okay, of course we need a stopping condition, so if the input is empty, then we can return the output. That's hopefully clear. Yeah, and then what do we have to do? So in general, so here we are lucky. The first element in our sequence only has a single ingredient, but in general that could be anywhere. So we should sort our input first, maybe. Okay, so we have to provide a key function and a collection. That would be our input. Okay, and then our function takes some item of that input and must do something with it, or compute, look at a part of that item and then do something with that. So in our case, the item is allergen and ingredients. Right? So that would be the allergen, those would be the ingredients. And what we want to do is count the ingredients. So in that way, we sort by the count of the ingredients in an ascending order. So the one with only one remaining ingredient should be at the top. I missed a T here. Okay, let's see if that still works. Yeah, so that gives us exactly the same because it just so happens that the input is already sorted, but that's not always the case. Okay, cool. And then maybe let's bind the result of that sort. So let's call that, I don't know, sorted. Okay. And then we can immediately destructure again. So what are we interested in? We are interested in the initial vector here. So let's call that initial. Okay, and then we are interested in the rest of those pairs. So let's call that, I don't know, more. Okay, and then the initial, we can destructure that further and can say we're interested in the allergen and in the ingredients. So let's do that here. We're interested in the allergen and the ingredients. Okay, so that looks good. A line already gets quite a bit long. Maybe we should do it like this. Okay, cool. And then, unfortunately, we can't destructure the ingredients singleton set. We can't say, destructure that and then it's only a single one. That doesn't work for sets. There you can see it nth not supported on this type persistent hash set. That's a bit unfortunate. So we must have another variable ingredient that is the first of those ingredients. Okay, we don't do anything with the let. That's why this is nil here. Okay, but I think we're almost there. So what do we now want to do? Of course, we want to recur, and we have to provide new values for the input and for the output. And maybe for the output, that's a bit simpler. So let's do the output first. We want to associate to the output the allergen and the ingredient. So that will basically put dairy and mx into the output. Okay, and for the input, basically we want to use more. So that will give us this here. Yeah, but then we still have our mx here. So we have to use the more, but remove the mx from the sets. Okay, so how would we do that? So let's loop again and say the allergen and the ingredients from more. And then we want still the same allergen, for example, the soy. Okay, and then we want to disjoin from the ingredients the ingredient. Okay, so that should work. Let's see. Dairy mx, that's looking good. Fish sq and soy fv. Yeah. Cool. Very nice. So the implementation looks quite complicated, but I think the algorithm is understandable, right? Always sort, so the singleton set floats to the top. then associate dairy with mx, remove it from the input, and then remove mx from all the set and the remaining input. Yeah, I think that should be understandable. Okay, cool. So now what do we actually want to compute? So if we parse our foods and look at that, then we have, for every food, we have a complete list of mentioned ingredients. And if we look at all the ingredients, then some ingredients will be mentioned multiple times. That's okay. We don't want to filter them away. So for now, let's look, basically at all the ingredients. Maybe let's start with some lead bindings. So those are our foods. Okay. And then we want to map the ingredients over those foods. Then we get that. That's okay. Those are the ingredients. And then I don't want a sequence of sets. I want to basically flatten those sets out. I just want a single sequence, but with duplicates. And we can do that by applying concat. Yeah, and then we have a sequence of all the mentioned ingredients. Okay, so maybe let's call that, I don't know, ingredients, the mentioned ingredients with duplicates. Okay, then let's compute our certain ingredients again. That would be certain ingredient of possible ingredients of foods. Right, if you remember, that looked like this. We just computed it. Right, and now we know that those are the ingredients that cause, potentially allergic reactions. So we could say, let's just look at the vals. That should be mx, sq, and fv. There we go. And then I want to put them in a set, because then I can use it as a predicate, and you will see that that makes sense. So let's call that allergic, like this. Okay, cool. What do I mean, use it as a predicate? For example, I can say remove allergic from ingredients, right? So this will take the ingredients sequence and say every element inside that is also contained in the allergic set should be removed. So now only the harmless ingredients remain. Let's call it harmless, right? And you can see that some are mentioned twice. So it's not the harmless ingredients, is the mentioning of the harmless ingredients, or the harmless mentioning of ingredients. And then we are supposed to count them. There we go. And then we get 5 for the small input, and for the large input I get 2461. That's the accepted answer. Okay, cool. And for part 2, it gets even simpler. We can just have a nice processing sequence here. So we parse the foods, that's nice. Then we compute the possible ingredients like this. Then certain ingredient like this. Okay. And then we're supposed to sort them by the allergen. And again, it just so happens that they're already sorted by the allergen, but in general, we can't know that. So let's sort. Now you can see instead of a map, we get a sequence of pairs. That's perfectly normal. And then we are supposed to look at the second elements of those pairs. So I could say map second, because we're only interested in the ingredients. That works. But instead of map seconds, we can also just say vals. Vals usually only works for maps, but for sequences of pairs, it works just as well. Okay, so now we have our ingredients, our allergic ingredients sorted by their allergens, and now we're just supposed to put commas in between them. And we can use the string join function, passing a comma, and that looks good. And if we use the large input, we get the expected result. Okay, cool. Yeah, so from a Clojure perspective, we didn't learn anything too exciting. So again, we used the set union to compute the union of input sets, the set intersection to compute intersections of sets. Then we have our good old for loops with filters. Then we have nested sequential destructuring, even deeply nested. That's often quite useful. Yeah, and the rest isn't really that exciting. So we use the vals function multiple times, which explicitly states it's only for maps, but again, works for sequence of pairs just as well. And the string join function with a separator is quite nice, and it's also quite efficient because it just uses a Java string builder and then a loop recur. So it probably doesn't get much more efficient than that. Yeah, and the sorting, well, looking at this algorithm here again, you could say, isn't it quite expensive to always sort the input, right? We did it here, the sort by. So in general, yes, sorting is, n log n or something. But since the input, let's say the input is almost sorted, then sorting is quite efficient. So sorting it again and again by the count, where the count rarely changes, should be almost linear in most cases. Feel free to disagree with me. How can I be so sure? So if you look at the implementation of sort by, it uses the sort, and sort under the hood uses Java util array sort, and that has been using timsort since, I think, Java 7, so almost 10 years now. And timsort is optimized for non-random inputs that contain already sorted sequences. So yeah, maybe I could do it in a more efficient way with some, priority queues or something. If you have a better approach, as always, let me know in the comment section below.